take it out, you just set it where it goes, or you can unroll it. We use rolls for, I don't know, 25 years until I started running my own company, and then we started using sheets. Sheets are so much easier to deal with. With a roll, you roll it out, and then you have to flip it over, and you may be rolling 50, 75, 100 feet out at a time, depending on the length of the slab. And then you have to physically roll this 6-foot sheet over that's 70 foot long and wants to roll up on you. And since it's been rolled, it looks like a wave all the way down through there. It's a headache. It's better than nothing, but it's still a headache. The sheets are flat, and you just carry them out, lay them down like plywood across the thing. You don't have to worry about it. You have to tie them together, but you don't have to worry about them bowing up and everything else, unless you drive them. Here's what they look like. That's what a sheet looks like. Here's how they're designated. So the longitudinal spacing and the transverse spacing, so 6 by 6 means that it's 6 inches by 6 inch grid. W means it's smooth wire, a D means it's deformed wire, and then the wire size 1.1. So this is 1.1, but this is probably the most common size. Lots of times sheets come in 8 by 8. All the rows that I've ever had were all 6 by 6. Why do you want 6 by 6 rolls? Because if I'm rolling it out 100 feet long, I can count every other piece, or every piece is 6 inches. So I can literally walk down through it and go 6 inches, 1 foot. Or I can go 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, and I know how long it is, so I can cut it. So I'm out there in the grass, I don't have to measure every single piece. If I have spaces that are different than that, a lot of times you end up having to count, you have to get a tape measure, measure every piece, and it's a lot harder to do. On sheets, it's super simple, because you walk out there and you set it down, you walk out there and you set it down, when you get to the end, you set it down, you either cut it to fit that little corner, or you just overlap it wherever it needs to overlap. And you got double reinforcement for 2 or 3 feet. Here's a bunch of different sizes, 6 by 6, 4 by 4. Masonry, division number 4. So brick, there's all different types of brick. Building brick, face brick, glazed brick, fire brick, paving brick, and then you have CMU. What's the CMU?
Concrete.
Right there, that's CMU. Concrete masonry unit. It's not a brick. So someone says CMU, but they mean a concrete masonry unit. It's this right here. Why don't they call it a block? I don't know.
Unit.
They're all, that's a block wall, right? This is a block wall, right? That's a common statement, but I don't know. I don't know. So I don't know why they call it a CMU. Don't get me wrong, everybody uses slang, but for the most part, on a set of plans, it's going to say CMU, concrete masonry unit. All right. You have clay tile and stone. So CMU, brick, clay tile, stone. There's CMU. That is horizontal reinforcement, so that lays down just like the wire mesh does in your mortar joint. So they mortar joint everything in, and then they lay this reinforcement down. It strengthens your wall laterally. You got different types of mortar. You got type N, which is high compressive. You got type S, is high strength. Type N is medium strength. Type N is what we normally use. Type N is the most common used medium strength general use. O is low strength, non-low bearing. Why would you use that? I have no idea. The only reason that I would think that you would use a low strength is if you're needing to grind some of it or clean it up or whatever. K is extremely low strength for interior applications, so maybe something you're gonna tear out, put in and tear out, put in and tear out, or might tear out in the future that doesn't need any strength. Types of brick. Adobe brick is made of dirt. Kiln burnt is made of clays that are molded to shape and dried for hardness. Sand lime, concrete, building is a common brick, and it's used for both the inside and outside. Types of brick. So you got a face brick, which is what we would put on the outside of a building. A glazed brick has a certain type of coating on the outside. Most of the time it's slick. A lot of glazed brick in schools, in bathrooms. That way they can clean them really easy and stuff doesn't penetrate into them. A normal brick has a little bit of a porous surface. So I'm gonna say this: you can get in a high school boys bathroom and they're peeing on the wall. It's gonna soak up and absorb that in the brick. So a glazed brick is really good for a bathroom because it's not gonna absorb the smells and the chemicals that you put on it. Hallways are glazed brick in high schools, especially the high schools built in the 50s and the 60s. You walk down through them, they have a slick surface so that they can wipe them and clean them and keep sanitary. Fire brick are used for extreme heat. A lot of times inside the fireplace itself. That's pretty much the only place fire brick is used, is in where it's directly connected to the heat. The chimney itself is not fire brick. It's where the heat is. So inside a stove, inside a fireplace, inside a boiler, something of that sort. Paving, we use on roads and patios. Here are brick symbols. So on an elevation, a small brick just lines. A large scale looks like this. Common brick in section is just a diagonal line. A face brick in section is a diagonal line, but it's closer together than the common brick. A fire brick has vertical and horizontal lines, vertical and diagonal lines. You can't really see it very well in here, but they have lines that run like this and vertical. This just has tight diagonal lines. This has a little bit bigger diagonal lines. Stone normally looks like stone. They draw it like stone. Cut stone is just a block. There's nothing in this one. Rubble looks just like the face brick. Concrete is a bigger box. Cast concrete is just a block. Concrete in section is the same as face brick. It's a little bit bigger than face brick, a little bit smaller than common brick. You really can't tell. You just know that there's something in section. Cast and cinder looks like concrete. Tile. Here's the one that this is a direct X pattern, 2 diagonal, that's tile. Glazed tile is got a little dot in the middle of the stuff. So here are some patterns, brick patterns. We have regular brick pattern, but you have a common bond. You got one, it's like 4 inches. This is like a 4-inch by 4-inch brick, and it's just a row. It's called a common bond. A lot of times they used to use these common bonds for strength. So they would put a bunch of reinforcement in a common bond, or they would turn them sideways where you got a hole so you can run a rebar down them, something like that. A running bond is just a normal laid brick, half across the top of the other. An English bond is where we have a full brick, a partial brick, a full brick, a partial brick, and then you have a row that has all partial brick, and then you have a row that has couple full bricks and a partial brick, and it, you just goes. I've never seen this one, an English cross bond that looks like random. A finished bond, I've seen this, long brick, short brick, long brick, short brick, and then they stacked is they're all in line. Why would you want to stack? I guess you can run rebar vertically and horizontally in this, it wouldn't be any issue, but I think this is just an architect picking out something different. Because this is definitely not stronger unless you have rebar core. All right, so this is the more important one. So this is a stretcher. Laid correctly like a normal brick, it's called a stretcher. If it's turned sideways and you're just seeing the end of the brick, it's called a header. If it's standing up facing you, it's a sailor. If it's standing up facing you, it's a sailor. If it's standing up with its shoulder to you, it's a shoulder. It's a soldier. Okay, sailor and soldier. So if it's standing up facing you like this with the wide point at you, it's a sailor. If it's standing up like this with the narrow side facing you, it's a soldier. A roll lock is a header turned on its edge, and a roll lock stretcher is a stretcher turned on its edge.
So if you were to tell me to go, how would you tell me to go do that? Like, will be
I'm going to give you a picture.
Okay.
But when you walk up to a wall, you can look and say, these are soldiers, these are sailors. I'd tell it. It's neat to know, but it's really not necessary to know unless you're the bricklayer. If you're the bricklayer, they're going to give you a pattern, and they're going to show you what the pattern is, and you go from there. For example, here, this is just stretchers. This is a header. So with a header, a lot of times you got 2 rows. Here's a soldier. You don't have to have 2 rows with a soldier. Here's a sailor, so that's inset a little bit because they're narrower. Here's a row lock. So you got row lock stretchers on edge, and then you got your row lock in like this. This is a row lock stretcher. These are the row locks. They go together. And this is just a regular course block. Types of masonry. You have a single width, so you have 1 brick. You have a composite, so now we have brick, block, or tile on one side. You got some header bricks in, tying them together. You got regular on the outside. You have a cavity, which is where you have sets of inside and outside, and there's a space in the middle, and a veneer. This is 99% of the brick laid today is in a veneer. In other words, it's just for show. These are actually structural. This is just for show. Brick, for the most part, in today's is just for show. Concrete masonry units. Variety of sizes. The standard size is called an 8 by 8 by 16, but it's actually not 8 by 8 by 16. Its actual size is 3/8 inch smaller than that because we have a mortar joint, and the mortar joint is 3/8 of an inch. Okay, so it's 16 by 16 because with one mortar joint, it's 16 by 16. Without a mortar joint, it's 7.5 or 7 5/8, 7 5/8 by 8 5/8. Here's a clay tile. Stone masonry, you got granite, limestone, marble, sandstone, slate, cut stones, all this kind of decorative stuff. Here are different, they're basically just drawing what it's going to look like here. So that's a random rubble stone, that's a forged rubble stone where it's all cut and fit in. Like, guys, there's some secrets to laying this stuff. Bricklayers don't like random or web. Why?
Not uniform.
It's not uniform. It's not level, square, and plumb. So what you'll find out is even in this, even the guy that drew this, you can see a little bit, they've got stuff laid in here where there's continuous rows all the way across. A good stone layer will be no pattern. There will not be a pattern. A brick layer that's laying stone, you will find a pattern. He will look for pieces to fit holes. A random guy, there'll be odd sizes, odd shapes. The mortar joints won't be consistent in width and size, and it looks better. But that's what it's supposed to look like. It's not supposed to have the same width. If you look, the person that drew this is used to drawing this kind of stuff because their mortar joints are pretty much common size. They're stacking stuff in here where it fits. If you see a random guy breaking a stone to fit in a hole, more than likely he's a bricklayer. Because the way it's randomly, my grandpa was a fantastic stone mason. Fantastic. One of the best ones I've ever seen. And he would get, he always complained about bricklayers laying stone because he said they want everything to fit. He said, but it doesn't look good when it's fit. Unless it's meant to be fit, like this coarse rubble over here. How he laid it and how he taught me how to lay it was you put a gigantic pile of stone behind you. So I'm looking at the wall and the stone is behind me, and you reach behind you and you pick a stone randomly. You don't look at it, and you pick it up and you put it on the wall. You can turn it, 2 or 3 times, but that's the stone that's going in that spot. And then you reach back and you grab another one and you randomly put it in there. Because if you do anything but that, you'll create patterns. So I would pile. So when I was a kid, I went to the creeks all over southern Illinois, and with buckets, and would fill pickup trucks full of stones. I walked down the creek and I pick up random stones. You wanted them to be about 2 inches thick. You didn't really care what they were. Fill the buckets, take them to the truck, dump them in the truck, go back. And I walk the creeks and I would get truck after truck after truck of stuff. And we would go and we would just unload them on the job in a line about 4 or 5 feet away from the house. And he would reach behind him and grab one. Reach to the other hand, grab one, reach, and he's just constantly laying. It was really, I learned a lot, but that's just information for you to know. A lot of times now we pretty much have brick masons laying this stuff, so when you look at it, it doesn't look as good as it used to. Here's some masonry accessories like bond beams. So above that door over there is a bond beam. It's a U-shaped concrete masonry unit that you actually fill full of concrete and put rebar in it. And that creates a concrete header across an opening for lintels and openings and headers. Metals, used extensively in construction, stud beams and joists, metal studs, windows and doors, ferrous metals and non-ferrous metals. So ferrous metals contain iron and are magnetic properties, iron and steel. Non-ferrous contain no iron and have no magnetic properties, such as aluminum, brass, copper, bronze. Did you guys know the reason why copper and aluminum won't stick a magnet to it? It's because it has no iron in it. If it had iron in it, you could stick a magnet to it. Okay. Surface treatments such as chroming, galvanizing, rusting, and electroplating. So chroming is, you guys know what chrome wheels are, chrome bumpers, right? We're just putting a coating across the outside of it and polishing. Galvanizing, we're actually taking zinc and we're electronically connecting it to the metal around around the outside of the iron to stop it from rusting. Zinc doesn't rust very well. It does rust, but it doesn't rust easily. It's resistant to it. We can actually rust a piece of metal, and if rust becomes a protective coating over some metals. What I'll tell you is for a I-beam or something like that, rust is not a protective coating, because what ends up happening is flaking happens, and when flaking happens, it actually kind of starts working like water does when ice happens. It actually starts expanding, and whenever you have it trapped and it rusts, metal expands a little bit, and if it rusts a lot, it expands a lot. So it'll crack walls, it'll crack all kinds of stuff. So we don't want rust to happen when we've totally encapsulated something. Electroplating is, we actually put a coating that's applied. Anodizing, you guys ever seen anything that's anodized? So like, a lot of times aluminum, we literally charge the electro, and then we can dip it or anodize it. So we put a powder up in the air and it attaches to it, and then it melts and it changes the color and puts a finish on the outside of it. It's really cool. We used to do it when I used to own a factory that built aluminum risers for compound bows, and we anodized a lot of stuff and dipped a lot of stuff. No, powder coating is different. Powder coating is you actually spraying powder in your electronic, and then you're baking it on. Anodizing electroplating is you're actually basically taking a negative ion metal and taking another liquid or a positively charged, and they bond together like gosh, a magnet. Metal gauges. All right, I always have problems with metal gauges. I don't know why I have issues with it, but if you look here, a 4 gauge is the weight per square foot is 9 pounds, is what I'm looking at. The thickness is 0.2242. And then as the gauge gets higher, the weight goes down and the thickness goes down. Alright, so if someone says they want a 12 gauge metal and they want something a little bit bigger than a 12 gauge, it's not 14, it's 10. Does that make sense? It's kind of the backwards of what you normally, bigger is actually smaller. Gauges work like that, so that's why I dislike the way of gauging. I would rather than say, I want 3/16 metal or 1/4 inch metal or 3/8 metal, because that fits along with something I can measure, where on a gauge, I either have to find the measurement and change it to the gauge, or I have to come up with some other way to do it. So for example here, this is 4 gauge and this is 16 gauge. Can't really see it very well, but the 4 gauge is bigger, 16 gauge is smaller. Structural steel joist, metal fabrication. So structural steel is this. It's the skeletal steel of a building. It's what's above our head. All right. Shapes. So the term applied to hot rolled sections, shapes, and plates includes bolts and rivets and bracing. So structural steel is this type of shapes that's basically the structure of the building, and you include the bolts, rivets, and bracing into structural steel pieces. So there is no such thing as an I-beam. You'll hear me say it every once in a while. It looks like an eye, but it's not called an I-beam. This is called a W. It's a wide flange beam. So the flange is wide, and a W beam, alright, so a wide flange beam starts when when you're ordering one or you have one on the job site. You're looking at W, and then it tells you the thickness, how deep it is. Alright, so 12 inches from outside to outside. So W12 is a wide flange, 12 inches tall. And for every 1 foot of length, it weighs 16 pounds. So a W12 by 16 equals a wide flange beam, 12 inches tall, and it's 16 pounds per linear foot. This is important because you'll get one that's 12 pounds, you'll get one that's 8, you'll get one that's 24 pounds, you'll get one that's 32 pounds. This is the strength, and this is the size. The more steel there is, for the most part, the stronger it is. So the more steel there is the heavier it is. So 12 is the height, 16 is the strength, or the weight per foot linear foot. All right, on an L, piece of angle, an angle iron, it's an L. So angle is L. L 3 by 3 means each leg, which is the height and the width, is 3 inches by 3 inches, and the thickness is a 1/2 inch. So it's a 1/2 inch thick, 3 by 3. Now, let's see if I can zoom in on this. All right, so wide flange shape. This is a wide flange. Miscellaneous. I don't know, you can't really see it very well, but a wide flange, or a W, the flange is all the same thickness from edge to edge. Alright? When you get into American Standard beams, which is an S or an M, it's thicker in the middle than it is on the edge. So that's one way you can tell a W from an S or an M. Miscellaneous shapes is M. An S is thicker in the middle of the flange and thinner at the edge of the flange. Okay? Why is that?
Because Americans eat a lot of calories.
No, it's because it's an S. S is structural, so it's stronger by having the material near the web. It won't rip away from the web. The web is, this is the flange, and this is the web. The vertical piece is the web, the top piece is the flange. So the flange, thicker near the web, means that it won't rip away from the web easier, so it's structural. They're all structural, but it's more structural. So an S. So you have an S 8 by 23. That means it's 8 inches tall and 23 pounds per linear foot. Alright. A C looks like a C. An MC is what they call miscellaneous channels. They look exactly the same. I don't understand the difference between MC and C. Maybe the MCs are special orders and C's are standards. I don't know. Then you have an L with equal legs and an L with unequal legs. They're both L's. I don't understand why they normally don't designate them separately. It's just an L. An L with a 6 by 6 or an L with an 8 by 6 by 1/2 inch. This is a WT, which means that the top is a W flange, which means it's the same thickness from edge to edge, and it's a T shaped, so it doesn't have the bottom flange on it. And MT is just like the other, and ST is just like the other. It just doesn't have the flange. This is a Z. It just just doesn't have the bottom flange on. Make sense? Woods and plastics. What time is it? Okay, here we go. Alright, woods and plastics. So, woods, plastics, and composites. Wood is high strength and compression and tension. Not as high as steel, but, I mean, when designed correctly, it's good in both of those situations. And uses structural framing, rough carpentry, trim, doors, floors, cabinetry. Types of wood, hardwoods is on one side, softwoods are on the other. Basically, if it has the characteristics of oak, maple, or walnut, or hickory, it is a hardwood. If it has the characteristics of fir, pine, or cedar, it's a softwood. If you notice, poplar isn't on either side of this. Lumber classifications. So we have rough sawn and surfaced. Rough sawn is not dressed, a surfaced is plain. Plywood, we've already been over plywood in the last class. Plastics and composites, gutters, downspouts, ornamental moldings, blue lambs. Alright, so thermal and moisture protection is roofing, damp proofing, insulation, weather barriers, flashing, sheet metal, insulation, openings, glass, float glass, types of glass. You have bent glass and safety glass, insulated glass, pattern glass, stained glass. I'm going a little faster because this stuff really, we've either been over it before or we're going to go over it again. Drywall. So there's lots of different types of drywall. You have regular drywall, moisture resistant drywall. A lot of times they call that green board. Because a lot of times moisture resistance is green. You'll put it in the bathrooms, you'll put it in around showers, you'll put it where you have moist conditions. Foil backed, it is just a regular drywall, but it's got foil on the backside. It helps reflect temperature back into whatever room it is. So let's say you got some type of high heat in a room, it'll reflect that heat back into the room. Also, might be able to use it in, that's the main use. Fire resistant. Fire resistant is called fire rated, is really what it's called. But all drywall is fire resistant. Okay? But fire rated is 5/8 drywall. Okay? Or if you put more than one layer of 1/2 inch down, then it's fire rated. Okay. I've never seen abuse. Soundproof, cement board, square edge, tapered edge, common thicknesses. Alright. Ceramic tile, quarry tile, paver, stone, all of this is considered tile, but it's not all considered ceramic tile, so I don't know why they put ceramic at the top of this page. This should say tiles, because ceramic is a type of tile, quarry tile, metal tile, stone tile, concrete tile, those are all types of tiles. Now, we use Portland cement, latex adhesives, and epoxy to put in tiles. All those 3 different types. Typically, we use grout, which is a cement type product for the mortar joints. Here is some different types. So this is a ceramic tile, just straight up and down the arms. The grout is dark, solid, cementatious backer board. This is actually cement fiber board that they put on the floor. They draw it as cement, and this is installed on concrete. And now you see, why are they showing concrete on both of these? Because wood is flexible. Agreed?
Yeah.
Concrete is not flexible. It cracks. It doesn't flex, right? So tile is not cracked. It can't flex, or it'll crack. The mortar joints will crack. The tile will crack. So you almost always have to put some type of super hard, they call it hardy board, underneath tile to stop it from cracking. And hardy board is a cement fiber board. Cannot lay tile on a wood floor without putting something over it. It will not work. All right, types of flooring. VCT, vinyl composite tile. That's what's in the hallway. All right. Solid vinyl tile is fake vinyl flooring, wood, like fake vinyl wood. These are all different types of material symbols. Earth looks like 3 lines one direction, 3 lines another. Concrete block. Look in the book and learn these. Structural steel shapes. I would say, look at the PowerPoint, but it's so light you guys can't see. All right. So where site selection? I've already talked about this a little bit. Energy efficiency. All right. I think what they're trying to say here, without saying it, is you pick your material based off of all of these things. You base your, whether you're going to use pervious concrete or non-pervious concrete, or what you're going to, how you're going to build, what material you build, based off your site selection. All right. Energy efficiency is another way to pick your materials. Another classification. So windows with low thermal transmission would be a good thing to have. And of course, you're going to pick all of these materials based off this material selection. And it says talks on about recycling. I don't care anything about recycling. Avoid materials that emit bad stuff in them. And so, for example, prior to 1980, a lot of the insulation contained formaldehyde. It's one reason why even today, when you pick up insulation, it will say no formaldehyde or non-formaldehyde, because it was so prevalent in the 70s to have formaldehyde in your insulation, which is fine, but it off-gases. So it's proven that it causes cancer, it causes asthma, it causes all kinds of issues. And, cancers and death and everything else, especially when it got wet. All right, so it would off-gas. So now you'll see non-formaldehyde insulations, and it's on everything, because it was so bad back then, the older people still worry about it. You guys didn't even know that. Did you? Did you guys know that there was formaldehyde? You did? Abby, did you know that?
Yeah.
So, so a lot of times we want to make our material selection based off that. And it says long-term building performance is water efficiency. So we're picking a shower or a tub, water efficiency is good to look at. Alright. That finishes up that chapter, which I went over really quickly. Wednesday, we're going to do an assignment based off of that chapter. I don't know exactly what it is yet. I'll look at the chapter and figure out which one. But we'll do it during class. And the main thing that I want you to review, and you guys got 30 minutes to do it right now, or you can do it in the next couple weeks, is all those material indicators. So what they look like in cross section, what they look like in plan view. In the book, it's got a bunch of examples. So look at those. I'm not saying you have to memorize them. And our midterm has a few of them on it. So it wouldn't be bad to get an idea, but I'm gonna show them to you before the midterm, so you're gonna be able to look at them. But I'm just telling you that you need to know that. Especially, I'm gonna say dirt, gravel, concrete, tile, what wood looks like in section, what wood looks like in plan. You need to know that stuff. Hardwood in section has like wavy lines, like the grains of the wood. Framing material in section is just an X. Alright, you need to know that, because if you're looking at a plan, you need to know what you're looking at. And those are, not every architect is gonna use the same exact thing, so I'm not overly concerned about you memorizing the little things, but the big things, like what wood looks like in frame section, gravel, concrete, those are all pretty standard across the everybody, so those are good to know. And you almost have to have them memorized, because they're not gonna, since they're so common, they're not gonna call that out on a set of plans. You awake? You want soup, bro?
No.
It's all good.
Well, I did see that the Eagles were up at half, but they lost.
Yep.
Yeah.
Everybody was confident. Rigged.
Mm-hmm.
Rigged.
I honestly think that every year that happens,
The refs won.
I really think that they script it.
Yep.
And if Eagles are winning by a considerable amount at half, people will dump more money into betting on the game, because you can bet all the way up until the last quarter, even in the last quarter. And then, bam, we come back with a comeback win. So people are thinking, I'm gonna bet, I'm gonna bet $500 the Eagles gonna win right now. You know, at halftime. I think it's Vegas.
And that's not the only stadium where you can actually go in there and place it right in.
Yep.
So I bet there was a lot of that.
So that's probably one reason why Kansas City's been getting so many. Is because we can bet right there at the place.
It's all rigged. Scripted.
I mean, look, I did hear that he was injured before the half.
Yeah.
Did hear he was injured before the
High
half.
ankle sprain that he
Yeah, and they didn't know he was gonna be back, and you know,
Yeah.
and then he comes back in the second half and looks like a hero.
Yeah.
Right?
Touchdown every drive.
Roger Goodell really knows how to write a good script.
I agree.
It kinda threw me off when he slid in for the, three touches.
I didn't watch it. No, I don't.
Yeah.
Yeah, he slid. I don't watch football.
Oh, no. I got a wallet.
Alright, you guys got 27 minutes.
With this touchdown, he could've just ran that in there.
I was recording to you at that time. It's your time. 27 minutes.
Strong like Popeye?
I think it's like 2 or 3
I got 3 years for the warranty period for the electrical water heaters. Don't know why. She said the starting time. And I wrote down for 19. What is the warranty period for the electric water heaters? You said it's from the start of the time it was installed. I'm just saying I got something different. I don't know if I'm right or whatever, but I'm just saying. How many semesters have you been in this program?
Sorry?
No, how many semesters have you been in this program?
This is my 2nd semester.
Um,
Yeah.